All right. Thank you for coming to my talk about an overview of AndroidX Test. I'm Michael Bailey. I'm a principal engineer at American Express. You can find me on Twitter at YogurtEarl. Today I'm going to giving you kind of a whirlwind tour of a number of different APIs, but also giving you some foundational information so you can see how the different pieces fit together, and hopefully some of the details under the covers will help you if you ever need to troubleshoot some of these things. So we don't have enough time to go into detail on all these things. So for some of the things, I'll just be pointing you to the documentation and hopefully giving you enough information and enough context so that documentation makes a bit more sense. I'm kind of assuming today that you've written an Android app. I'm assuming that you've at least written some unit tests in at least some language, maybe not Android. But I'm also assuming you haven't written very many Android tests. And this is kind of information that will help you get started and point you in the right direction for hopefully writing more Android tests. And maybe I'll get you some some common pitfalls and give you some pros and cons of the available options. All right, so let's jump in. So there's two main types of tests that you're going to see and encounter in Android testing. If you generate a new project, you're going to see these two folders. You've got Android test and you've got test. And especially if you've never written Android test before, you might be wondering what the difference between these two folders are. So we're going to kind of cover those differences. At a high level, Android tests require a device and an emulator that get compiled into an APK. You run the full Android build, and it runs in the context of your app. The stuff in /test runs on a JVM locally, not in the context of Android. It's very similar to what you just get with a plain Kotlin build with Gradle, or a plain Kotlin Java build with Gradle, where you're just running JVM tests on JVM that's running on your host machine. So first, we're going to dive into this test folder and understand what's going on there. So if you've ever written JVM tests, you've got a great foundation for what's going on here. It's basically the same. But if you're applying the Android plugin to your project, now you're getting additional things kind of inserted into your test flow. You don't need an Android emulator. You don't need a device. It's going to run on your local JVM. You can still run them like you normally would any Java test with Gradle W-test. You can run them through Android Studio. And when you want to add dependencies to those tests, the ones in /test, you're going to use the test implementation configuration in your dependencies block of your Gradle file. There's no dexing involved. There's no AAPT involved. It doesn't have to compile resources. So potentially the build is faster for these types of tests, and the execution is faster as well. So that's one of the advantages of these types of tests. So let's take a little closer look. So this is kind of the sample test that gets generated when you create a new project. It just shows you that you can assert anything. It's just normal Kotlin code that you're running. Of course, isn't super useful. So let's dive a little deeper. You're going to run it with Gradle test. We see that it passes. Great. You can also just run it through Android Studio with a little play icon in the gutter and hit play, and it's going to run it, or you can debug it right there. It gets a little more interesting when you want to actually use Android from your tests. So TextUtils is part of the Android text package. It's an Android class. It is available because there's an Android jar that gets inserted by the Android Gradle plugin into the class path. So this will compile. It will try to run. If this is all you do, you're going to quickly get to a place where you're running into a little bit of trouble. So if you run this, you're going to get the method not mocked exception when you try to run it. That method, the concat method, is going to throw an exception. And this is because the Android jar that the Android Gradle plugin inserts into your class path basically has no implementations for everything. Every method just throws an exception. So any of your code that touches any Android API in this context, if by default is going to throw this exception that you haven't mocked that that method. So because of this, this is one reason why various architectures are very popular on Android. So you've probably seen a lot of presentations on MVP or MVVM or MVI or something similar, where the core idea is to take your logic that powers your app and separate it from all of the Android classes. So you put your logic into your presenter, depending on which one you're using, and then you test your presenter, and that just has the logic. It doesn't really reference the Android code, and so you're not going to run into problems with it like this if you're referencing an Android class that's then going to throw an exception in your /test, and you can more easily use the /tests and just test the pure logic of your application code. Sometimes you're trying to run tests on an existing application. Maybe the architecture doesn't really lend itself to separating it from the Android UIs, or there's something specific that you just can't quite get away from the Android classes to test. So you need a bit more support here. In the simplest case, maybe you just want it to not throw an exception. And then in that case, you can just set this test options return defaults equal true. And what this does is it swaps out that implementation that we just saw that says method not mocks and throws an exception. It basically just, it does nothing and then returns the default value. So if it's an integer, it returns 0. In this case, text_utils.concat returns a char sequence. So it's going to return null because that's the default value of a char sequence. But at least you're not going to get an exception. So if your test doesn't directly depend on that method working correctly, it may get you by for some certain types of tests. And generally, you're not going to be calling an Android test directly. Like this is just simplification for not going to be calling Android code directly in your test like this. It's a simplification for slides. Generally, this text_utils.concat or whatever other Android method will be deeply nested in some code of your app. But if it gets triggered, you don't want it to throw an exception. And in some cases, returning the default value is not going to quite work. And you're going to get something that doesn't quite make sense. Like here, we're expecting it to return, the concatenation of these 3 strings, and it's returning null. So in this sort of scenario, this isn't quite going to get us there. But for certain small number of cases, depending on what you're trying to do, this may be enough. So the next thing you might try is to use a mocking library. And this is the library that goes in and you create instances of classes that have basically the bytecode swapped out for some mocking implementation that allows you to verify later or control what the implementation does. And you can use this against Android libraries. Here, in this case, it's a little bit trickier because you're mocking a static, which is always dangerous. I don't recommend you don't do that. But in this case, we're mitigating that a little bit by using a use clause, which is part of Kotlin, to scope the mocking of the static. And then we're providing, a method or a value that it's going to return. And sometimes you just need like that one method to do something, and the rest of your code is not really tied to Java. And this just gets you over that hump and allows your test to work. And again, don't do this directly. Like here, this is kind of a nonsense test. We're just mocking, something and then calling only the mock. So we're not really testing anything here. It's just an example again to show that if your code was deeply nested, had a call to text_utils.concat, and you needed it not to throw an exception or not to return null, you could do something like this. If at all possible, I recommend just avoiding mocking libraries altogether. They often, they're easy up front. Often you end up having to do a lot of troubleshooting when they don't do what you expect, or the next person that reads that code has to kind of parse through and see how all your mocks are set up and things like that. Often you could just use the real implementation of something, or you can use a fake wrapper around it that has a fake implementation, in-memory implementation of something. But if you need to use a mocking library, Mockito is the most popular one. It has good Android support. For Kotlin, you might want to use this library called Mockito Kotlin that takes a few rough edges off of Mockito with nullability and some other things that make it a little bit easier to use in a Kotlin context. Some of these libraries, depending on what API version you're trying to support, you're going to run into problems with older APIs that didn't support certain types of mocking. So just be aware that depending on what you're using the mocking library for, it might only work, and which version of the mocking library you're working with, it might only work on newer API versions. The next option is to use something like Robolectric. I think I spelled the domain name wrong there, but this you have to put in a test options, include Android resources equals true. You add it to your test implementation, Robolectric. You put on this run with clause that says to use the Robolectric test runner. And what Robolectric does, it actually downloads the Android framework code and gets it to run within your JVM through a lot of hackery and reflection. It sort of inserts actual Android code into your JVM flow. So when it works, it can be great if you want to run your tests on a JVM. In this case, it's going to work great for something simple like this. It actually puts the real implementation of concat from Android in here. It downloads the implementation of Android that matches your target SDK. So if you target SDK 29, by default, it's going to download the Android code from SDK 29 and put that into your flow here. For our target SDK 29 and above, your local JVM that you're running on needs to be JDK 9 or above. Some of the downsides of using Robolectric is it's fairly fragile because of all the magic it's doing underneath the hood and swapping things out with reflection. When you go to a new target SDK, you're often going to run into issues there, and you might have to tweak things when you go to you might have to get a new version of Robolectric, and you might run into other problems that you're going to have to sort through when you go to a new target SDK. When you upgrade your Android Gradle plugin version, sometimes there's incompatibilities there. So the downside is that future version upgrades of other things outside of Robolectric might cause you some additional work. The other side of things is tests that would be really fast or maybe a little bit slower now. So just in this case, which is a one-line assertion that really does not much of anything at all, takes over 2 seconds, almost 3 seconds if you see from the screenshot there. So as you start to do more and more with Robolectric, you can definitely see a pretty big slowdown in some of your tests. So just be aware of that. But it is an option that's there for you if you need to run real Android code within a JVM context and don't want to have an emulator or don't want to have a device available to run. So that's /test. Now we're going to move over to /AndroidTest. This is where you actually compile a test APK. It gets installed onto an emulator or onto a device. A full Android operating system is running, and you're basically running the application code in an Android process along with your instrumentation code added onto that. So let's look at that in a bit more detail. All right, so you might have heard these tests called instrumentation tests. So what is instrumentation and why are they called that? And is that different than an espresso test? So let's see. There is a class called instrumentation, and that's why it's called an instrumentation test. This has been around since API 1. And instrumentation is not really at the very highest class level. Of raw instrumentation is not necessarily specific to tests, although that's usually the main use case that it's always used for. But it allows you to basically insert hooks into the execution of an Android application and kind of control and instrument it through a kind of sort of a side mechanism. So let's see how that works. So you would put something like my instrumentation into your Android test. You would, and then you would add an Android manifest to your Android test there. And let's see what goes in each of those. So here, my instrumentation extends instrumentation. And there's a bunch of things you can override from the instrumentation. Here we're just overriding 2 main lifecycle methods. In some ways, this is similar to your application object lifecycle, but this is a separate instrumentation object lifecycle. Here, we're not doing much. We're just printing out a few things. But you can see the onCreate method gets past the list of arguments. And then it's generally calls a start method That start method then calls onStart on a separate thread. It creates a new thread, and we'll see that when we look at what this prints out, that it's on a new thread. And then you do whatever you're going to do with your instrumentation. Generally, that means invoking a JUnitRunner that's going to go out and look at your tests and invoke your tests. But none of that is built into instrumentation. That all comes as a subclass of instrumentation up to the implementation of that instrumentation. So to actually get this to run, it needs to be added to your manifest. So you would create that class. It's a subclass of instrumentation. You would put this into the manifest of the test. So notice the package name up top is example my application test. Then you put this instrumentation block in there. And notice that we're targeting another package. That is the package of the actual application. So we have this test package or this test APK that's instrumenting a application package or application SDK, and you tell it which class is going to get those life cycles, sort of like how you specify if you override application with your custom application invocation. If then we go to Gradle and we just say install debug and install Android Test, it's going to compile both of them. You see here that it installs two separate APKs. App debug is your application code. App debug Android Test is your the test code. In this case, it contains my instrumentation. Then you can verify that they were installed. We see there's two packages, two separate things installed on the device with ADB. You can do ADB shell PM list packages. And there's another command that we can use called ADB shell AM, and that has a subcommand called instrument here. And that's the details of instrument actually vary a little bit on newer APIs versus older APIs, but if you just run ADB shell AM, it gives you all the kind of subcommands that you can use there. We're not going to worry about too much of this today, other than to just pass in the instrumentation that we want to trigger. So now if we go back and we look at the thing that we saw a few slides ago, we see our custom instrumentation implementation that we overrode. We extended implementation and override some of the methods. We invoke ADB shell AM instrument with the name of the APK that contains the instrumentation. And then that command knows to load it up. It's going to read what's in the manifest. Remember, we put the information in the manifest. It's going to go and start example my application, and it's going to then execute the instrumentation in that process. And if we look at what it prints out here, notice that onCreate actually gets started in the main thread. And then when we call start, it creates a separate thread called the instrumentation thread, and it invokes your onStart method. And then you would do something like invoke your JUnitRunner or whatever else you want to do there. So this is kind of why it's called an instrumentation test. This is a core functionality of Android that's existed since API 1, and you can build all sorts of things on top of this. It gives you the hooks there. If you want to learn a bit more about like the main thread versus the instrumentation thread, there's a talk I did a couple of years ago called How the Main Thread Works that you can go for more details on that. So if you notice here, there's an arguments bundle that gets passed into onCreate. So this can be used for whatever you want, really, but it's a way to customize what your instrumentation is doing. For example, you might want to say, wait for the debugger so you can attach a debugger before you go and execute your tests or whatever you're going to do. In this case, you can pass -e debug true, and then you can look up that value in the arguments bundle. And if it's true, you can wait for a debugger. You can also do various hooks with your custom instrumentation. You can actually override the new application when it gets created. So this gets called when it's trying to create your instance of your application object. You can either return a test application object if you wanted, or you can get the real application object and maybe inject it with something that's special for tests or do something there. You can also override the creation of the object creation for every activity that's going to be loaded in the process. And there's a whole bunch of other hooks that you can look at in instrumentation that allow you to hook into the process. Interestingly, the new application callback is one of the very earliest callbacks that you'll get when you're running under instrumentation. I think it gets called before all your content providers. It gets called before you're on Create. So if you want to do something very early in the process life cycle when you're running under instrumentation, you can also use the new application callback to do that. So all of what I've said here is kind of complicated. You got to add stuff to the manifest. You got to call like ADB shell. Like if you've ever written an Android test, you're probably like, I've never had to do any of this, and this seems a little crazy. Well, you can, if you don't want to know the nitty-gritty details of how it all works, you can kind of forget what I just said. But when you're debugging things, it can come in very handy to know kind of what is going on under the covers. You don't really have to do any of that because the Gradle plugin does, and Android Studio do all of this sort of for you. They take care of all of this for you. You just have to bring in the AndroidX test runner, and you have to point your test instrumentation to the Android JUnitRunner, and pretty much it'll do everything for you. It adds the right things to the manifest for you. It does all that dance I just described for you. You don't have to worry about any of that unless you're trying to debug that something that didn't work as expected, and then it's nice to know about some of the details. So why does this work? Well, Android JUnitRunner is an instance of instrumentation. So if you look up the class hierarchy of Android JUnitRunner, you'll see that it implements a few classes that ultimately extend from instrumentation. Monitoring instrumentation adds another set of hooks in to the lifecycle and allows you to do some additional things, but it doesn't really have anything to do with running tests. And then Android JUnitRunner extends on all the monitoring instrumentation stuff. And then in its onStart method, it actually triggers JUnit, and it calls JUnit, which goes off and executes all your tests in the start method. And that's why it's on a separate thread, because the start method is executed from a separate thread that is created by instrumentation. But again, the Android Gradle plugin in Android Studio will do all of this for you if you just put the right things, like I showed, into your Gradle configuration. If you notice here in this test that would get executed if you're using the Android JUnitRunner, there's a way to get a handle on the instrumentation. If we were doing the my instrumentation thing I showed before, this would return an instance of my instrumentation. In this case, in most cases, you're going to be using Android JUnitRunner, and it's going to return an instance of Android JUnitRunner. But that also comes with a handle on your target context and your context. And it's important to know the differences here because you might need to use one or the other. Target context, remember we saw in the manifest, there was a target package. That target context is referring to the package, usually your application that is being instrumented. And then the instrumentation is the actual context. So depending on which one you're looking for, which APK, if you're trying to access resources from one APK or the other, because there's two APKs here, you need to either go for the target context or the context. So it's important to know which one is which. And we saw that you can pass arguments into an instrumentation. Android JUnitRunner has a whole list of arguments that you can pass in that could probably be a talk on its own about all the details. A couple that you might be of interest is the debug one, and we saw how that is implemented. You just look in and say, is this debug true? Then you just call debug wait for debugger, and that's how Android JUnit implements that. If you read at the reference there, you'll see all these different commands. Another interesting one that you may have not come across is this disable analytics equal true. By default, Android JUnitRunner actually phones home every time you run tests to collect analytics on how many tests are being run. If you don't want that to happen, you can turn that off with this flag. It's by default, it's on. And one way to do that and to do these flags, you can pass them through the command line through ADB shell AM instrument, or you can also pass arguments through your Gradle configuration. So here I have disable analytics equals true. And so anytime either Gradle or Studio run my instrumentation, it's going to be set, it's going to pass in that argument. Now, if you run it through the command line with ADB shell AM instrument, it's not going to get passed. Or if you run it on something like Firebase Test Lab, it's not going to get passed in, only when through Gradle or Studio. So let's say you wanted to just hard code this and say, I don't care how my instrumentation got invoked, I just always want this to be true, disable analytics. Then you can actually do a custom JUnitRunner, and you could just insert that string into the arguments bundle before you call onCreate, and that argument will be hard coded always to true no matter what context you execute that in. There's a lot of different use cases for having your own subclass of JUnitRunner, Android JUnitRunner. Whether you want to, like I said before, that new application callback, new activity callback, there's a lot of hooks into the various things that are going on, maybe just for logging or for some other purpose. You should look at all the methods that you can override in Android JUnitRunner and see if there's anything there that that can help you. And then if you do have a custom JUnitRunner, you just put that into your Gradle build file, test instrumentation runner, and then that will put it in the manifest in the right place so that gets invoked as the instrumentation. And of course, you can just read things out of the arguments bundle if you want to customize the behavior of your JUnitRunner and add your own arguments in addition to what comes out of the box with Android JUnitRunner. All right, so we've kind of seen how these tests get bootstrapped through using this instrumentation API, and then you pull in this thing from androidx.test, this JUnitRunner that invokes JUnit. So ultimately, you're invoking a test like this. But remember, there's two different threads here, the instrumentation thread and the main thread. Your test is running on the instrumentation thread. So Espresso, where that comes in, is that's a library that basically does synchronization between the two threads, because you don't want Espresso to try to click on a button before it exists and then your test fails. So it generally will try to wait until your app is done doing what it's doing and then click on the button, or then try to check for whatever text you're checking for. So there's a lot of documentation on Espresso. It's been covered elsewhere, but that's how how Espresso fits on top of these various layers. It's just a library that gets compiled in with your instrumentation and has methods to do all this synchronization. I have a separate video that dives a bit deeper into the details of Espresso, and it allows you to assert on various view states, and it synchronizes for you with the main thread. So after all this is done, again, you can just run this as we saw before with anim instrument, or you can just run connected Android test. And that will do all of this for you. So all the stuff that I just told you, you don't have to worry about it too much, because if you just run connected Android test, it's going to build the right APKs, it's going to install the right APKs, and this is going to then, you don't have to do the ADB shell instrument. Gradle W connected Android test will just do that for you. It'll do everything that you need to execute the test, and then it will grab the results back off the device. And if anything fails, it'll give you a link to the test results there. But Gradle is doing all of this stuff under the covers for you. But thankfully, it just gives you one nice task that does everything, so you don't have to worry about it. You can also just run this through Android Studio. Clicking on the gutter in Android Studio, again, will go through and it will install the right thing. It will invoke the right ADB command to invoke your instrumentation. It will collect the results off the device. And in this case, it will you can see on newer versions of Android Studio, it will run them on multiple devices. So I have all devices selected here. You can see it ran 2 tests on 2 devices, and it shows you kind of in a matrix which tests it ran on which devices. And in this case, they all, the test passed. All right, so one thing you're going to run into fairly quickly as you start to write more and more tests is these tests are running in the process of an Android app process, and it runs one test method after another, and it doesn't really reset anything. So if you have one test method that leaves over some state or leaves the UI up or does write something to disk, and then another test method comes along and assumes that there's a clean state, you might get into conflicts where, because of the ordering of your tests, they fail. And then the ordering is not deterministic. So if you add a new test, it could kind of reshuffle the ordering of all your tests that you're running, and then you get flakiness. So the solution to that is to use Android Test Orchestrator. And this gives you a couple benefits. This is kind of, again, the low-level detail of how you might run it. You download these APKs from maybe not Google, you install them with ADB, you run ADB shell, and this is a long shell command that I don't have time today to kind of break it down exactly what it's doing here. But this would go off and trigger Android Test Orchestrator, which then in turn triggers your application. And what Android Test Orchestrator does is these APKs that you're installing are running as a separate process, and then it's executing one test method at a time. So it starts up your process, executes one test method, gets the results, kills your process, executes another test method in a separate new instance of your process, and then shuts it down. And if you see in the middle here, it's where it says clear package data true. That actually is going to tell the test orchestrator to delete basically everything you've written to disk in your the private area, the private space of your application. So you even get a clean disk between every test invocation. The downside is that it's slower. The upside is there's no state left over. If one test crashes, it can just, that process is gone anyway, and it'll just keep executing the other tests one at a time and new process every time. Whereas before, if you have a whole list of processes and it's all trying, or a whole list of tests and it's trying to do them all in one process, if one fails, it's just not going to be able to execute the rest of your tests because the whole process is gone once your test crashed. So you get one test failure, you fix that one, you run it again, you get the next test failure. In this case, it's going to run them all, even if some of them fail. And so you can get all your failures all at once, rather than kind of doing this whack-a-mole of one test failure at a time. The downside, like I said, is being slower, but past a certain point, it just really doesn't scale to write a lot of tests unless you're using something like Android Test Orchestrator. Again, you don't need to write all the stuff I have shown here. This is just like what Gradle is doing under the covers, basically, to get Android Test Orchestrator to work. If you just add these few lines of configuration, it's going to do all that for you. You just have to add the test options execution. You've got to write Android test util and point it to the right version of Orchestrator. And then again, you can pass in things like disable analytics or the clear package data equals true into your orchestrator. Now, one interesting thing that you'll notice, and it's not super important, it may never matter for your use case, but if you just tell Android Test Orchestrator, hey, go run all my tests, it's going to run them one at a time and each in a separate process. But to do that, it first needs to query your process and say, hey, give me the list of tests. So you'll see if you're looking at the logs, in addition, let's say you have 10 tests, you'll notice that it started up your process 11 times. Because the first time it did that, it passes in this argument to your instrumentation saying list tests for orchestrator equals true. And AndroidJunitRunner knows that, when I see that thing, I am not going to run any tests. All I'm going to go do is go look at all the tests, enumerate them, and send them back to Android Test Orchestrator so it actually knows what to execute, because I didn't give it a list of anything to execute. So just something to be aware of is that there's always this extra invocation with this argument passed into your instrumentation when you don't tell it specifically which tests you want to run, and it needs to go enumerate those. But if you pass a specific method in and say only execute this one method or this list of methods, it doesn't need to do that because you've already given it the very specific list of methods it needs to execute. All right, so we've talked about the two types of tests, the pros and cons of each, the context of each. One interesting thing is a development within the last couple of years, came about 2 years ago, and Roboelectric, as of version 4.0, now supports androidx.test, where they were both, before that, kind of separate things that didn't play well together. So as of 4.0 that came out about 2 years ago, you can actually run Espresso on JVM tests using Roboelectric. So it used to be when people would use kind of instrumentation test and Espresso test interchangeably. Espresso was just the library used within your instrumentation test. Now it's not a good replacement for instrumentation test because you can write Espresso tests on your JVM in your /test directory using Roboelectric. You can use activity test rule, you can use fragment scenarios, and increasingly more of the AndroidX test APIs are able to be used within Roboelectric. One tip is you may get to the point where you're writing a bunch of both types of tests and you want to share some of the code, because you can reference Espresso in both types of tests. You can reference, things like the Android scenario rule in both types of tests, activity scenario rule in both types of tests. So you may want to take some code out and share it between your two types of tests. The way you can do that is create a separate library at the Gradle level. It's an Android library. You put your shared test code in there, and then you just import that project into both your test implementation and your Android test implementation. And the code goes in the main of the shared library, but then you pull it into the test and the Android test to share that. So just a few pointers on Espresso. For most things, you're just going to use on view, and then that has various assertions and mashers that you can do, and you can call perform to interact with the UI. But for certain things like recycler view, there's a specific dependency you need called Espresso contrib that has view actions that know how to deal with the recycler view. For drawer layout, there's some there, and there's a few extra other things listed if you go to that link there. Unfortunately, for most of the material components, there's no library I'm aware of that knows how to interact with those specific components. You can go to their own tests in the source code for that library and pull some of the code out there that they have in the test for the material components. We'll show you how to interact and give you examples of view matchers and view actions and how to interact with material components if you go to that link there. You won't get too far with espresso testing before you get into a situation where espresso is just not waiting long enough. Espresso is generally very fast, and it's very, it doesn't wait any longer than it needs to. Occasionally, it just doesn't wait long enough. Your button's not on the screen yet, and it's trying to click your button, and then the test fails. Generally, when you need espresso to wait just a little bit longer, it's because you're missing an idling resource somewhere. There's a couple built-in ones you can get, and they're all implementations of this interface. Hand rolling your own idling resources is something you can do. It's a little bit error prone. It's hard to get right. You can get subtle flakiness because your idling resources aren't quite doing the right thing. So you can use things like counting idling resource. There's a library out there called RxIdler. For most libraries, somebody's wrapped it with an idling resource. So maybe you can just go grab one of those depending on what it is that you think Espresso's not waiting for. And an alternative to hand rolling your own idling resources is also a library called BusyBee. This is my preferred way, but I also wrote this library, so I'm a little bit biased toward it. But it makes it basically so you basically tell Espresso when to wait because your app is busy with something, and then tell it when you're completed with the thing, and Espresso will continue. And it takes care of some of it. It uses idling resources underneath the hood, but it just makes it a little bit easier and a little bit less error prone. It also gives you better logging and easier to debug. And one thing is, sometimes you have a library that's only Java and only Kotlin. It's not an Android library at all, but you want to have an idling resource as part of that library. BusyBee you can use in a pure Java or pure Kotlin library, whereas the idling resource artifact is an Android artifact, so you can't actually import that into your pure Kotlin library. So BusyBee helps you with that scenario as well. All right, so assertion libs, to change gears just a little bit. So if you've ever tried to do a unit test, have assertions at the end, right? That's the main meat of the unit test, is you're asserting something is true. If you do something like this, where you're just calling assert true or using the built-in JUnit assertions, you're going to get very poor error messages. Now, this is an extreme case. Hopefully nobody's writing assertions like this, but you're asserting true here on this thing. You're looking for something in the bundle, and the error that you get is just assertion error. It tells you nothing. It's a terrible error. You get this when you get a test that fails, and you don't know where to start. You have to go read the source code to figure out what actually failed here. So because of this, it's very common to use assertion libs. Assert J, assert K for Kotlin, and truth is a popular one. AndroidX provides extensions to the truth library that help you with Android APIs. So if you're doing assertions on things like bundle or things like intent and certain Android APIs, you can get extensions to truth to help you with that. If you're using assert J or assert K, you might just have to write your own extensions to those libraries to cover the Android APIs. So just as an example, when you use an assertion library, you get a much better error message rather than just assertion error here. It allows you to do things like contains exactly. So just using assert true, it's hard to say like the logic to say it contains exactly these things, nothing more, nothing less, is a little bit tricky. Here you can say that fairly easily, and when it doesn't happen, it gives you exactly blow by blow what went wrong. You're trying to get the string array list of foo. It was missing bark, and it had an unexpected extra value of bar, and then it shows you the expected, and it was this, and then it actually shows you there's other stuff in the bundle too. Maybe that's what you were looking for. So it gives you the context of like what everything was in the bundle. A much more helpful error message. An error message like this is going to make it readily apparent right away what the problem was, so you can fix your tests faster. So use the AndroidX truth extensions to get nice error messages like this. And that is all I have for today. So I know that was a bit of a whirlwind. I talked fast, but thank you for sticking with me. All right, so I see I got the questions here. So let's see, why not use Mach-K for Kotlin instead of Makito? You can. They don't play well together. So if you already have Makito in your tests, Mach-K it has some conflicts depending on the versions you're using. So mixing them is a bad idea. My preferred approach is just to use nothing. Like don't use Makito and don't use Mach-K for either. Mach-K and now Makito in the new versions mock things like do mock static and they mock final. You're going to get a lot of trouble with those sorts of things and potentially very hard to debug tests when you start getting into things like that. I much prefer, whenever possible, to just either use the real implementation of something or to use a fake implementation, meaning I don't use a mocking library. I just use some Kotlin code to create an in-memory implementation of an interface and then assert on the state of the interface or the state of this object after the fact, rather than trying to call verify on methods and swap things out. So yeah, I would recommend using neither if you have a choice. But if Mach-K works for you, that's fine. Just be aware that it sometimes can conflict with Makito. Any recommendations on best practices to test an app in several languages or manipulate the emulator locale? I don't think I have any recommendations specifically for that. I would say, the best practice is that any context that your test or that your code that you're trying to test depends on, pass it in as a dependency, right? This is what dependency injection does. Even if you're not using a dependency injection library, don't rely on the default locale. Always pass in the locale to your code, and then your test can just pass in the locale. That goes for a lot of things. Don't have your test rely on the time, the system time. Don't have your test, rely on any sort of context where it's kind of just assuming, things like the file encoding. It should not use the default char set encoding. It should use a hard-coded one like at UTF-8 or pass in the char set that you want to use. Same goes for locale. Pass in the locale, and then in your test, you can just pass in the locale from your test, is my recommendation. Why insert the Android.jar in the class path if any will throw an exception? Well, they give you the thing where you can swap out the implementation for the default return value, but yeah, it's not super useful. Other than if I want my stuff to compile, right? And I don't want to get like class not found. So just having the Android.jar there for certain scenarios, having an Android.jar will prevent class not found errors when it tries to load up a class and then it sees that this class that you're trying to test reference an Android API, but maybe the code that you're trying to test doesn't actually use that Android API at all. So it's not a problem if it throws an exception, but you don't want just the mere fact that you have an import statement for an Android API to cause your tests to fail. So there's certain classes of tests where having the Android jar in the class path prevents class not found errors. If using a fake instead of a mock, wouldn't I be risking having bugs in my fake code? Yes, but you have the same problem with mocks. That's why if the real implementation is not too heavyweight and it makes sense to use the real implementation. But a fake, mocks are sometimes quicker up front when you write them. When you're coming into code that you're not familiar with and you're reading through all the mocking stuff and seeing how it's set up, any time that you saved on the upfront of not writing a fake maybe and because a mock was quicker is usually paid for down the road by having to debug the mocks, where you can just set a debugger and step-by-step through your fake code. So it's a lot easier to figure out your fake code. But yeah, again, you can write bugs in your fake code. So you could just reuse the real code if that works for your scenario. RoboElectric does not work well with modules and is slower than normal view tests. Yes, there are definitely downsides to RoboElectric. It's a nice tool if you're willing to get the caveats of it being slower and potentially having conflicts with the way your Gradle is set up, or the new version of Android Gradle plugin, or the new Target SDK. You just have to be willing to say there's enough value in RoboElectric that we are going to be willing to basically pay the cost of maintaining it going forward, which is non-trivial. So if you can get everything done without RoboElectric and just have like a nice MVP or MVI model where you don't really need RoboElectric because you've kind of separated your logic from the Android classes, that's definitely preferable. Or just use Android tests. But what are the most valuable use cases of overriding the instrumentation class? I would say you almost never want to just override it directly. I was using that more as an illustrative, like here's how it works. Here's what AndroidJunitRunner are doing. I would say if you're going to, you're always going to override AndroidJunitRunner, unless you're doing something really custom, but very few and far between. So, most of the time, 80% of the time, you probably just get away with plain old AndroidJunitRunner. And then sometimes you want to override it to be able to hook into certain life cycles, or maybe add a bit of better logging of certain things, or you can maybe do some, inject some test dependencies by some of the hooks that you get there. Is analytics on even if you disable it when Android Studio asks for a data collection on startup? As far as I know, yes. I think it's two totally separate things. Espresso and the AndroidX.test stuff is just, AndroidX.test runner is just a dependency that you're choosing to add to your APK. And Android Studio, while it has some integration and makes some things easier, it doesn't directly know probably about those analytics. So I'm guessing yes, but I haven't actually verified that. So if you're really concerned about those analytics, definitely the best case is just to override, provide your own subclass of AndroidJunitRunner. What are your thoughts on setting up Android tests into CI? There's a number of different ways to do it. There is a blog post out there on, I think it's either the Android developers, I think it's on the Android developers blog, where they provide Docker images of Android emulators for you. So you can spin up Docker images. There's a bit of coordination you have to go there where you have to spin up a Docker image that contains an Android emulator. And then there's various other services out there that provide, essentially devices as a service that allow you to run your implementation against those. So you can either try to manage your own emulator farm with Docker images on one of those, or you can just go out to one of the services that provides that out of the box. Is it possible to run a subset of tests with a new process for the same test run? Not sure I quite get that question. Only a subset of tests with a new process. Oh, like rather than each test in a separate one, maybe to like group them. I don't know that it is. I think it always just runs them in each method in a separate process. Android Test Orchestrator is open source, so you can fork it and maybe add that as a feature, add as a feature request, or have a custom version of Android Test Orchestrator that does that via parameter. It's definitely possible, but as far as I know, it's not supported out of the box. Recommend any UI test strategy for apps that need a user logged in. Well, I generally I say don't actually call real server from your Android tests. Use something like WireMock or some mocking layer that actually, not something like Mosquito, but basically an HTTP server or something that returns, stub responses or mock responses over HTTP. And then you can basically in your test say, okay, for this test, when you see a login request for this user, return with this response. And so you're controlling that tightly within the test, and not leaving it up to hoping some server is up and running and hoping that account is in a certain state. So I would say don't rely on any real implementation of a server running elsewhere. Tightly control that within your tests. UI Automator might be out of scope. Yeah, it was on my list of things to include. I just, it was too much to get in within my time scope, so it kind of fell off the list. It fell on the cutting room floor. UI Automator is more black box. It can go outside of your application. Espresso is only within your application. You can't click on buttons outside of your own application with Espresso, but you can with UI Automator. UI Automator can basically automate anything on the device. UI Automator is a lot more fragile because anytime you're going outside your process, other applications can change. Anything outside your processes can change. And so you kind of have to know, based on the accessibility IDs and things like that, how to interact with other things. But that's the main thing, is that UI Automator is kind of outside of your process entirely and just using accessibility services basically to automate things on the device, your application, other applications, whereas Espresso is actually inside your process and is actually inside your main thread, looping through your main thread and clicking on things from within your process. But Espresso can potentially be a lot faster and a lot less flaky. So that's the advantage of Espresso. Why deprecated Gradle features? Oh, I think in some of my messages there I had deprecated Gradle features. That might just be something, I think it was the Android Gradle plugin, might be using a feature of Gradle that's going to be deprecated in Gradle 7.0. So I think it has something to do with the interaction between Android Gradle plugin and Gradle version 6.7. The combination of those two. All right, I think we're out of time. If you can tweet more questions at me at Yogurt Earl, and we can engage there. But thank you for coming.